Assalamualaikum warahmatullahi wabarakatuh. I, Noel Fadil Yusuf, represent my group mate to our mini project which entitled Prediction of Vehicle Fuel Consumption based on Fuzzy Inference System. First of all, I would like to introduce my group mate, which we have Muhammad Shukri, Chef for Design, and then we have Noel Natasha Binti Paiman, and we have Maizatun Nasifa Binti Yusri. Fuzzy Logic has seen a significant increase in the number and complexity of its applications during the last several years, which we call FL. And then application for interpreting the image as edge detection, feature extraction, classification, and clustering have used FL methods. So the fuzzy logic can effectively use ways of reasoning that are approximate rather than exact by modeling the workings of the human mind, decision and action in classic high computing um, based on accuracy, certainty, and intensity. So logic is a study of the elements and rules of sound reasonings. More specifically, it aims to define the rules that ensure the reliability of the deductive arguments.
The objective of this research is first to acknowledge the fuzzy logic and second to identify the prediction of vehicle fuel consumption based on the fuzzy inference system. The significance of this study is that the driver will learn how to achieve the goals to save the consumption of fuel. The method of fuzzy inference system will be used as a measure tools to calculate the parameter of engine capacity and speed for the consumption used. Therefore, as a result of this study, we will know how to minimize the energy consumption of a car. Next is literature review. Fuzzy inference is a process of applying fuzzy logic to creating a mapping from a given input to an output. The mapping then serves a base for making decision and identifying the trend. Membership function, fuzzy logic operators, and if-then rules are all used in this fuzzy inference process. The volume of fuel consumed by an automobile to travel a particular distance is measured as a fuel consumption. It is measured in liter per 100 km or gallons per 100 miles in nations that use the imperial measure.
The technological advances that accompany rapid economic development make energy becoming key issues for the world community. Cars as a mode of transportation today and the future also continue to progress both in terms of quality and quantity. The size of the current car quality is not only located on the engine capability and ride comfort, but also on its fuel consumption. In the past years, fuzzy inference system, which is based on expertise expressed in terms of if-then rules, has been employed in different subjects. Fuzzy inference system can be used to predict uncertain systems, and its application does not require knowledge of underlying physical process as a precondition. So here, I would like to present the application of FIS to fuel consumption efficiency problem. The fuzzy inference system for this problem takes speed and engine capacity as inputs and compute a fuel consumption percentage using the following rules. Rule 1. If speed is low and engine capacity is low, then fuel consumption is less efficient. Rule 2. If speed is high and engine capacity is low, then fuel consumption is less efficient. Rule 3. If speed is low and engine capacity is high, then fuel consumption is less efficient. The result of the rules are combined and distilled. Then will be shown the result of fuel consumption efficiency in a Cripps number. Predicting motor vehicle fuel consumption has become a critical issue since it is tied not only to the supply of fuel but also to the environmental damage caused. Managing the usage of motor vehicle fuel is one of the fuel-saving methods. Fuel management is required, particularly for individual car owners. The essential information on motor vehicle fuel consumption and vehicle characteristic is concerned in order to correctly regulate the usage of fuel. This data can be used as a starting point for forecasting the fuel consumption of automobiles.
Now we will proceed to the next part, which is part B, MATLAB tools for solving fuzzy inference system. In this study, fuzzy inference system were used to forecast the fuel consumption of automobiles based on their speed and engine capacity. The goal of this study was to understand more better ways using notions of fuzzy logic inference system. The MATLAB fuzzy logic toolbox simplify the creation of fuzzy logic system by providing command line capabilities. The program may be used to design fuzzy inference system. In this slide, this figure is the framework of inputs for components of fuzzy logic and output. Our input are speed and engine capacity, while the output is fuel consumption. For fuzzy controllers, it contains of four, which is fuzzification, fuzzy arithmetic, and applied criterion, and the last one is defuzzification. For fuzzification, it helps to convert inputs and allows you to convert crisp numbers into fuzzy set. Crisp input measured by sensors and passed into the control system for further processing. Fuzzy arithmetic operations are thus frequently used for solving mathematical equations that contain fuzzy numbers. It is the extension of the four classical arithmetic operations of crisp numbers to fuzzy numbers. The last one is defuzzification. Defuzzification is performed to convert the fuzzy sets into a crisp value. There are many types of techniques available, so you need to select it which is best suited when it is used with an expert system.
For the first step, we need to identify the input and output. As we can see here, we have two input, which is engine capacity and speed, while for the output is fuel consumption, liter per 100 km. For the second step, we need to construct the membership function for input and output. As we can see on the slide, we have three figures that show the membership graph for the input and output.
For step number 3, we have prepared 9 dashes of fuzzy rules as you can see on the slide. Then we proceed to step number 4, which is conversion of crisp dataset to fuzzy dataset. The membership is used to transform numeric input variables into their appropriate fuzzy set during the fuzzification process.
Next, I will continue for step 5, which is to evaluate the fuzzy rule base. Firstly, we will let the X to be the vehicle engine capacity and Y be the vehicle speed. For Z, it is considered as vehicle fuel consumption. Suppose that X is 1.3 and Y is 75. Then the combination of fuzzy inputs with the rules in the fuzzy rule base can be illustrated in the figure below. We will take rule 1 and rule 4. For rule 1, if vehicle engine capacity is low and vehicle speed is low, then the vehicle fuel consumption will be efficient. While for rule 4, if vehicle engine capacity is medium and vehicle speed is low, then the vehicle fuel consumption will be less efficient. For the other figure, it is about the aggregate fuzzy output of X equals to 1.3 and Y equals to 75 after we've done the both graph before this. I will continue with the step 6. Step 6 is the conversion of fuzzy output to crisp output. This is the membership function of vehicle fuel consumption, and the calculation below is performed by using center of gravity, or it is also known as the centroid method, to convert the aggregate fuzzy set of vehicle fuel consumption for X equals to 1.3 and Y equals to 75 into a crisp value. So the last step is step 7, which is implementation in MATLAB Fuzzy Toolbox. Fuzzy Inference System was using 5 editors in MATLAB, which is Fuzzy Inference System Editor Design, Membership Function Editor, Rule Editor, Rule Viewer, and Surface Viewer. So the first one is Fuzzy Inference System Editor Design. It is to design the fuzzy system logic and display general information of fuzzy inference system. Secondly, the membership function editor is to display the input and output of the membership function. The third one is rule editor, which describes the rule of fuzzy inference system. It is including the choosing for input variables, which are add or. So the fourth one is rule viewer. Rule viewer is where the result for the output variable will be shown when there is an input variable. And the last one is surface viewer, which is to generate the 3D surface from input variable, which are vehicle engine consumption, vehicle engine capacity and vehicle speed, and also the output variables for vehicle fuel consumption.
Based on this project, we can know the fuzzy ecosystem is constantly a fuzzy set irrespective of its input, which can be fuzzy or crisp. Next, we also can know it is used as a controller that helps to produce fuzzy output. It also have a defuzzification, which also will accompany the FIS to help in converting the fuzzy variable into a crisp variable. So in fuzzy inference system, there are two methods that help to use this system, which is mum learning and Sugeno. Mum learning is well suited in the human input. Mum learning also is more interpretable and rule-based in this fuzzy inference system. Lastly, the other method is Sugeno. Sugeno is well suited in mathematical analysis. It's also computationally efficient. Sugeno also help in guarantees the output surface inference continuity. So that is all from us. Thank you.